Alright, I'm going to record this video as an addendum, but this is a really long problem, and so it might just turn into its own video by itself. But what we're going to consider then is 14.4.5, which is one of the hardest homework problems you'll run into if it gets assigned. Otherwise, yeah, it's a slog, and a lot of kids don't understand what's going on. So hopefully I can clear this problem up. It's actually a very worthwhile problem to do because it really tests your understanding of if you know when to use the chain rule and when to use other like derivative rules. Okay, so this is the problem. If f is equal to w of u v, all right, so what does this mean? F is equal to w v. It literally just means that f is some function of u and v, and we're just giving that function another name that's w. Okay, so w and f really are interchangeable. You can think of them that way. It'll probably make it easier for you guys. So just think of w and f as the same thing. I don't know why we don't just stick to like f. Oh, it's because so then we can write this abstractly. I don't have to say, like for example, I don't have to say f is equal to 2u squared v cubed, right? I don't have to say that explicitly, but it's just some function of u and v, all right? And we say that's w. Okay, so it satisfies the fact that f double partial u, all right? So that's the second derivative with respect to u of f. And the second partial derivative with respect to v, if you add them together, that's 0, okay? And then we also know what u and v are. U is equal to x squared minus y squared over 2, and v is equal to xy. So we want to show that w satisfies wxx plus wyy is equal to 0. Another way you can think of it is that fxx plus f sub yy is also equal to 0. So that's what it is. And at first glance, this doesn't seem too bad, right? Because what do we do? Well, okay, so it looks like we need to take, we need to show that w sub xx plus w sub yy is equal to 0. So it looks like I just need to take a bunch of derivatives, right? And what does that mean? Well, okay, so so let's start out then, and I want to find w sub xx, but to do that first, I need to take w sub x, right? I need to take the partial with respect to x. So that's really, right, w, but I can't just write dw dx. Well, I want to write dw dx. However, notice that w itself, this guy itself, there's no x in it, right? Explicitly, I don't write any x's in there. So what do I have to do? Well, I have to use a chain rule, right? Because w is a function of u and v. So this then is equal to dw du dx plus dw dv dx, right? And so, oh, well, that's supposed to be v, okay? So again, this is just the chain rule. This is very, you guys should be familiar with this if you're looking at this video or if you're learning this for the first time. I explained this in the last video. This is exactly what the chain rule is, right? So, yeah, so remember, if I had w, and then I go to u, and then go to v, and then I had to go to x, well, that's exactly what we would have in our chain rule. So I'm going to write this then slightly differently. I'm going to write this as w sub u, right? So that's the partial of w with respect to u times u sub x, okay? So this guy matches with that guy, and that guy matches with that guy, right? It's just a reduced notation a little bit, so I don't have to write fractions over and over. And then this then becomes w sub v, and then dv dx is v sub x. All right? Okay. Cool. So that works. Along the way, I would kind of want to do this as well. We're going to introduce then, not introduce, but I'm going to follow this along where I actually know what w is, all right? So I'm going to say w is actually some function, and we're just going to plug it in on the right-hand side so it's not done completely abstractly. So for example, let's say w is actually equal to 2u squared v cubed, okay? So w sub x then would be equal to the partial of w with respect to u, all right? So take this guy, partial with respect to u, and that's going to be equal to 4u v cubed, right? And then u sub x, okay, so here's u. U sub x is going to be equal to, well, take the derivative with respect to x, and you get 2x, but then divide by 2, so you just get x, right? So you get that times x, all right? And then you add w sub v. So w right here, take the derivative with respect to v, you get 6u squared v squared. All right, and then dv dx, well here's v, and so v sub x, take the derivative with respect to x, and you get y, right? Okay, so we're just following along here. So, and then to make this even more clear, right, this is w sub u, this is u sub x, this is w sub v, and this is v sub x, okay? So hopefully seeing actual examples of what a w is and this abstract stuff, you'll be able to connect the dots a little better. All right, what's next? Well, now I want to take the second derivative with respect to x, right? So wxx, then that's the partial of wx with respect to x, right? Because it's the second derivative of w, or the first derivative of w sub x, which is the partial, okay, with respect to x. So I'm just taking the derivative of w with respect of w sub x with respect to x now, or the second derivative of w with respect to x. And what is that? Well, okay, so that's d dx of w sub u sub x, plus w sub v sub x, all right? And so we can distribute the partial w sub u sub x plus d dx w sub v sub x, all right? So here, what would that look like? That would look like d dx, all right? Or so here we're saying w sub xx is looking like d dx of w sub u sub x. So that's 4uv cubed x, right? Plus d dx of 6u squared v squared y, okay? However, what's the problem? I can't just take the derivative of this. It's really hard to, right, to just take the partial, because two things. Firstly, and we're going to deal with this first, is that, look, w sub u, these are essentially two functions multiplying each other, right? W sub u and u sub x are multiplying each other. They're two different functions. And here, if we isolate them, it becomes a little more obvious, right? You got some functions that have u's in them, and then you got functions that have x's in them, right? Because that's how we define w sub u and u sub x. So what we have to do then is that we actually have to use the product rule, okay? Just your plain old derivative product rule. And so what does that look like? Well, then that's equal to, right, u sub x times the derivative with respect to x of w sub u plus w sub u times the derivative with respect to u sub x, right? So this guy then becomes all of this by the product rule. All right, and then the same thing happens with this guy as well. You need to have v sub x times the partial of w sub v, all right? And then you need to add w sub v times the partial of v sub x, all right? So then let's do that with the example here. This becomes x times d dx of 4uv cubed plus 4uv cubed times the partial d dx of x, all right, plus or y times the partial with respect to x of 6u squared v squared plus now 6u squared v squared times the partial with respect to x of y. All right. And what do I get? Okay, so let's take a look now. This part's really easy, all right? So this term right here, this term and this term are really easy. Because why is that? Well, what's the partial d dx of u of x, right? What is that? This part just becomes, well, w sub u times u sub xx, right? Because u sub x in this example right here, right? Or even up here, u sub x is x, right? We see this, u sub x is equal to x. And so if you take the partial of this guy with respect to x, right? Well, that's really simple because that's just equal to 1, right? The partial of x with respect to x is just 1. So u sub xx is just that, and it's equal to 1. Okay, that's easy. What else is easy? Well, here I have d dx of v sub x. So I have this guy, and I have to take the derivative with respect to x, right? But v sub xx is going to be 0 because the partial of y with respect to 0 is, well, the partial of y with respect to x is 0, right? So then this part right here, right, this becomes plus w sub v times v sub xx. And so what do we get? We get w sub u times 1, right? Because u sub xx is 1, which we calculated up here. U sub xx is 1, okay? And v sub xx is 0. And so this term then at the end is just 0, plus 0. Okay? Great. So, and we even see that here, right, with our example right here, because we get, right, so this is the second term. d dx of x is then, this is 4uv cubed times 1. And then over here, d dx of y, well, then this should get plus 0. Right? So you get plus some term in the middle. You get this first term, you get plus that, and then you get that term, and you get plus 0. Okay. That's cool. We can work with that. What's the problem? Here's where it gets very tricky. Take a look at this. d dx of w sub u. All right. It's very, very tempting, right? And this even looks wrong to write this is equal to ux times w sub ux. Right? Why does that look wrong? Well, w has no x in it. W has no x in it. It has u's and v's, right? U's and v's have x in them, but explicitly w does not contain any x's. So this is nonsensical, right? Just taking the second derivative of w sub u with respect to x is nonsensical. And let's look at our right-hand side here, right? This right here is w sub u, all right? 4uv cubed is w sub u. How in the world are you going to take that partial with respect to x, right? 4uv cubed is w sub u. There's no x in there. How are you going to take the partial with respect to x? This is why it's so difficult. That's why this problem is so difficult. You have to apply the chain rule to w sub u. Okay, so we've got to apply the chain rule again. And how do we do that? Well, you do it exactly like you did before, right? You have u sub x on the outside, and then you're multiplying a bunch of crap, all right? All right. Now, the function that has to take the chain rule is w sub u, all right? It's w sub u. Well, we already know what w sub x is, right? We know what w sub x is. So this guy is really w sub u sub x, right? That's what we're trying to find. In order to find this, right, w sub u sub x, I just go up to my w sub x guy, and wherever I see a w sub u, right, I just add another u. So this becomes w sub u sub u. And this guy becomes w sub v sub u. All right, or w sub u sub v. It doesn't matter because remember we showed that cross partials are the same thing. So this can be w sub v sub u or w sub u sub v. It doesn't matter, right? So w sub u sub x is then you just add the u there, and for everywhere that had a w, you add u's. Okay, and so what do you get? Now I get w sub u sub u times u sub x plus w sub u sub v times v sub x. All right. Does that make sense? So this then is by the chain rule again. All right. Great. Well, we're not done because, all right, we already calculated that term. Now, what do we need to do? Now, I need to find v sub x times d dx w sub v, right? And again, d dx w sub v, that's w sub v sub x. Again, this is nonsensical, right? Because I have an x, attached to a w. So what do I do? Well, I have to do the chain rule for this guy as well. And we can see it on the right-hand side, right? Here is w sub v, right? And so if I have to take the partial, right, w sub v sub x, well, here it is. It's right here, right? This is d dx of w sub v. Yeah, it doesn't make sense. This w sub v is still a function of u's and v's. I still got u's and v's inside, right? And so that means when I take this derivative with respect to x, I have to use the chain rule again, okay? And how do I use the chain rule? Well, here I replaced w sub x with the u's, right? I just added u's whenever there were w's. And here we're going to do the same thing. We're going to do the exact same thing. So instead of saying w, but now, right, my function is w sub v, right, that I'm concerned with. So wherever I see a w, I'm just going to add a subscript v now. So w sub v sub x, which is what we want to find, is equal to w sub v sub u, all right, plus w sub v sub v, all right. And again, this would, like, you could write it w sub u sub v, w sub v sub u. They're the exact same thing because the partials communicate, right? That's what or partials commute, and that's what they're doing here. So w sub v sub u just means you're taking the derivative with respect to v, and then you're taking the derivative with respect to u, and then w sub u sub v, you're taking the derivative with respect to u, and then the derivative with respect to v, and they're the same thing. So, okay, we'll write like that. So everywhere you see a w, you add a v in the subscript. Cool. So that means this guy then becomes w sub u sub v times u sub x plus w sub v times v sub x. All right. And now, what do I get? Well, I know what u sub x is. U sub x is x. Okay, so this becomes x, right, times w sub u times u of x. Well, u of x we just said was x, plus w sub u sub v times v of x, which is y from above. V of x is y, right, up here in the orange. Okay, cool. And now I add w sub u times 1 plus v sub x, which is y, right? V sub x is y. Okay. So this is v sub x, so that's y, times w sub u sub v times u sub x, that's x. All right. Plus w sub v sub v times v sub x, well, that's y, plus 0. Okay. And to write it all out, what do we get? I get x squared WUU plus YWUV plus WU plus YWUV plus, or plus XY WUV. And over here I also get plus XY WUV. Oops, forgot to distribute this X out in front. Now I got to distribute this Y out in here. So I get XY WUV plus y squared WVV. All right, and this is w sub xx. Okay, that was a slog. All right, this video is already super long, and let's now finish it for the right-hand side, right, to show you guys what this looks like. So then this becomes x, all right, times, well, I got to take the derivative of this guy with respect to u first, right? So this is, I got to take d du, I got to take the derivative of this guy with respect to u, and then the derivative of u with respect to x. So that becomes 4v cubed. Okay, so 4v cubed, which is WUU, all right? And you can see that, right? W sub u is equal to 4v cubed, right? Because w sub u is equal to 4uv cubed. And we already had all that, so all right, let me write this off to the side a little bit. Let's see, let's use purple. So W sub u was equal to 4uv cubed, and so W sub u is equal to 4v cubed. Okay, so it's W sub u times u sub x. Well, u sub x is x, so times x, and then I got plus W sub u sub v. So W sub u sub v is a little more interesting. W sub u sub v, let's not write there. So now I have to take this guy and take derivative with respect to v, and I get 12u v squared. So now I get 12u v squared, and I also need a v sub x, which is y. Okay? And likewise, here I got y times, okay, this becomes W sub u sub v, W sub u sub v, which is 12uv squared, okay, times u sub x, which is x, plus W sub v, so W sub v, this is this guy with respect to v, so that's 6u squared v squared, and we had that already, and then W sub v is 12u squared v. So then this becomes 12u squared v, and then times y, because we want v sub x, which is y. All right? So this is what that function looks like if we said w was that. And this is what, then this is w sub xx. And this guy here in blue is w sub xx. All right. This video is running really long. I don't want to run any longer. So I'm going to leave the exercise to find w sub yy to you. Okay? So at home or whatever, you're responsible for finding w sub yy. I'll tell you what it is. You should get w sub yy is equal to y squared w sub uu. So do this part by yourself, using the exact same steps I did up above. All right, so w sub yy should be y squared w sub uu, all right, plus, then you get minus xy w sub uv, all right, plus, and now minus, I really want to add things for some reason, w sub u, and then minus xy w sub uv, and then plus x squared w sub vv. All right? And notice that like u's and v's, right, they might be switched. You might have them switched. It's okay, right? For partial derivatives, you can switch w sub uv and w sub vu. They're the same thing again. That's why partial derivatives being the cross partial derivatives, that's what these guys are, right? You take the derivative with respect to u first, then v, or v first, then u. That's why the cross partials being equal, that's why that's so important. It's because then we can do stuff like this. So finally, your last step is to show w sub xx plus w sub yy is equal to 0. All right, so if I add these two above, what happens, right? This guy cancels with that guy cancels with that guy cancels with that guy, all right? So all those guys cancel. I'm left with x squared w sub uu plus y squared w sub uu, right? I'm just adding these guys, all right? And then I'll add these guys, plus y squared w sub vv plus x squared w sub vv. And if I do some factoring, if I factor out a w sub uu here, I get x squared plus y squared times w sub uu plus, and if I factor out a w sub vv here, I get y squared plus x squared w sub vv. And now if I factor out an x squared plus y squared, right, because y squared plus x squared and x squared plus y squared are the same thing, I get x squared plus y squared w sub uu plus w sub vv. Hey, wait a second, right? Well, x squared plus y squared, okay, w and f are the same thing. So this is really f sub uu plus f sub vv, and we know what this is, f sub uu and f sub vv, right? It's 0. f sub uu plus f sub vv is 0. So this is equal to 0 because this guy was 0. Okay? And this proves that wxx plus w sub yy is equal to 0, which is what we wanted to show. All right? A lot of work on this one question. There's a reason why I did a video on this. It's very important, right? It's very important for you guys to see why this works right here, okay? And here, and then here's the numeric example that goes along with it. I highly encourage you guys to work out this step, to do this step yourself. Just do it. For your sake, understanding how to deal with dense notation is also very helpful. And yeah, and if you just follow the steps I did up here for w sub xx, and you just carbon copy it for w sub yy, you should get this guy right here, and then you should get the corresponding correct guy for this example on the right hand side in orange. I actually came up with this right hand side example on the spot, so I didn't actually check it myself, but you should get the right thing. So, all right, that's 14.4. Yeah, 14.4.5. This is a very difficult problem. It's worth your time to grind through it. Hopefully this video makes it easier and helps you guys understand what's going on. The important points to understand are that, w sub u, which is du dw, right? Remember, so w sub u is du dw. This guy right here. This guy and this guy. That guy and that guy. That's what they are, right? W sub u is still a function of u and v, so when you take its partial with respect to x, you still have to use the chain rule. You have to use the chain rule again, and we see that right here, right? We have to use the chain rule again. Got to use that chain rule again, and yeah, that's the most important part. So understand when you have to use the chain rule. Understand when you have to use the product rule, which also shows up here, and yeah, do that second part with w sub yy. I did half the problem for you. I told you how to finish the problem, and it's in your best interest then to finish this example.